revolving around y equals 8, that's a flat line like the x-axis. So that means that you'd be doing it dx. So draw your line in. If this is y equals 6, y equals 8 is up here. Will I have 1 r or 2 r's? 2. Okay, most of y'all on the test did okay on this. Your capital R goes from what you're revolving around to the farther away border. So I would go from here to here. And then my little r goes from what I'm revolving around to the closer border. That's my little r. And then remember, though, they're both top minus bottom. However, technically, remember, it doesn't matter if you put them backwards because you're going to square it anyway. Okay, so it'd be part B, volume equals pi integral. What are my endpoints? 0 to 2. And then my capital R is this line. What am I touching on top? Was it 8? Oh, I wrote the wrong number right here. It should have been 8. Okay, 8 minus, and then my bottom function is the 4ln. And then remember, that radius has to be squared together by itself. Okay, then minus. Then my little r is the difference between 8 and 6. You can write it out. You can simplify it. 8 minus 6 is really just 2 squared dx. Okay, then remember, since y equals 8 is a flat line, that's why we're doing it dx. Okay, go on to part C. Part C says we want this to be the base of a solid. We're going to be perpendicular to the x-axis. So that's going to be dx. Now, one thing to keep in mind, I'm going to redraw my picture for part C. One thing to keep in mind is that when you're doing the region of a base, it's not allowed to go outside the region. So if this is my shaded region right here, then my base should not go beyond that. So my base is going to be perpendicular to the x-axis like that. So remember, your r's are allowed to go outside when they're a radius, but your base is not. Now remember, my base is going to be top minus bottom. So that'd be 6 minus 4 ln 3 minus x. And then I need to think about the shape that they gave me. They told me that it's going to be a square. So how do you find the area of a square? B squared. Very good. And then remember, you just put an integral on it. Volume is always the integral of area. So it'd be integral 0 to 2. My base squared dx, where my base is this. And then as y'all are correcting your tests, a lot of the mistakes I noticed were people putting pi on everything. Remember that it really depends. If it's an equation that has pi in the area, then yes, it's going to have a pi. But if not, then you would leave that out. Okay? Good. We remember these things? Okay, turn the page. Alright, we are going to skip to number 5. We're going to do the ones that we don't need a calculator for first. So number 5, go ahead and do it for me. Okay, remember, just like on the mock exam, they're going to find your zero slopes first. So find what x would have to be 0, and I'll bring you candy. And then just do all the parts of that you remember how to do. Or do you guys want a Chips Ahoy? Which one? Chips Ahoy? So remember, slope fields are super easy. You're just plugging in the ordered pairs and then drawing a slope that kind of matches that steepness. Oh, or I have Oreo.
Oreo.
Okay. Someone said last time that Chips Ahoy were stale. So
What
I
kind of
don't
Chips
think
Ahoy
that
is
they're
it?
stale, but
You know?
I think it was.
Yeah.
You're welcome. Are you in BC?
Yeah.
Love to see you. Here you go. You're so welcome.
Wait, just make sure you do not take tutoring sessions.
He doesn't do anything? Do y'all review in class at least?
Yeah, but most people don't listen. That's the point.
Little cookies for you. Okay.
Are those real Oreos?
They are. Well, like they're offering.
I've never seen them in a box like that.
Well, so this usually is inside. It's like not reclosable, but they get stale faster in that than in like a real Ziploc. Because I feel like it doesn't have a very good seal, you know? Clutch. Okay. Then when you get part A, go on to B and C. What do you do? Oh, okay, that's fine. I thought you were trying to solve it. Oh, no, actually, okay, this needs to be for part C. That's where you're finding the particulars. So that's not wrong, that's just part C. Yeah, I have tissue, that's why I bought some. Yeah. This weekend, just for your sweet little nose. Okay, quick question. Which of these can you just automatically know the slope is 0 when x is what?
But what?
This will be 0 slope when x is what? When x is -1. That means all these guys over here were flat. Now, why is this row here blank? Because if y is 0, what would happen to your slope formula? That would have come out to put a divide by 0, not allowed. That's why you have to leave those blank. If you mistakenly put a line segment here, you'll lose your point. Okay? Then out of the remaining points, you're just plugging stuff in. So 0, 1. I'd be plugging in, I'd get 0 plus 1 over 1. So that'd be a slope of 1. Then I go up 1 to 0, 2. That'd be 0 plus 1 over 2. That's a half, so that needs to be a little bit less steep than the one right below it. Okay, then if I'm coming down here, this is 0, -1. So it'd be 0 plus 1 over -1. That's a -1 slope. And then if I go down to 0, -2, that'd be 1 over -2, which would be -1/2. And remember, these are very relative steepness to each other. Okay, you want to make sure you just don't have any going the wrong way. Okay, then over here I have 1, 1 and 1, 2. 1, 1 would be 1 plus 1 over 1, which is a slope of 2, so that should be a little bit steeper. Then go up 1, 1 plus 1 over 2, that'd be a slope of 1. Okay? And then etc. Bottom 2, you could do it. Now, do you have to show your work? Absolutely not. If you want to do it in your head, that's totally fine. Just make sure they're not going the wrong way. So then I have 1, -1. That'd be 1 plus 1 over -1, which is -2. So that one would have to be downhill. And then right below that will be -1, just based on the pattern. Okay? But those should not be hard if you remember, you're just plugging in points, drawing a little piece of a line. Okay, part B. While the slope field is drawn only at those 12 points, it's defined at every point where y isn't 0. Describe all points where y isn't 0, where dy dx is -1. Okay, this was the easiest thing ever. All that you have to do is set dy dx equal to -1. So if I let x plus 1 over y equal -1, okay, you've described it. You don't have to solve for x or y. Okay, I don't even know why that counts for a point. That seems really easy, but that would work. Now, you also could have multiplied the y up here and written it in that form. I don't know that that is any better. You'd get a point for either one, so you might as well just leave it, but that's good enough. Okay, part C. Anytime that you see particular solution, you should be separating. So if I need to separate my y stuff from my x stuff, okay, remember like on your mock, okay, just separating counts as a point itself. What will my separate step look like? Y dy, and then x plus 1 dx, and then integral. And remember that since the y was on the bottom, that's why it ends up on the top. Okay, so finish it out, make sure you get a plus C, and then make sure you go back and find your C at the end. Okay, and I love to help. I'm ready to help. Whenever you need it. Oh yeah, since it's already on the bottom, it'll time's up.
You laughed at me. Or you did your thing.
It's okay, we laugh at each other. We're family. We're a family of friends.
I have a question.
Yes.
Why? We don't get the y, right?
So when you integrate y, you get 1/2 y squared, and then dy goes with that. Correct. Huh? Yes?
So I have Amaraji's sister, and I do hour, right?
Uh-huh.
Today she came in, she had short hair, and I just started like laughing on the inside because you told me the story.
About her hair.
Well, you gave them names.
Huh?
You didn't give us names.
No. This was about this girl that she came in with, like, she'd had like real short natural hair, and then she came in with long hair, and I was like, I love your new hairdo.
You told us that.
Or haircut. Oh
Tell
yeah.
us the name of the person.
Oh.
She did.
Well, y'all are in different
She
classes.
told us it was you.
Oh, it was after school, wasn't it? Maybe I told you another day. Yeah, it was Amarachi. I'm friends with her on Snapchat now too. Yep. Okay, you should have this.
I do. Whoa.
Okay, then you should have times by 2.
Oh my goodness.
So this would be y squared equals x squared plus 2x. Remember that c, since I don't know what it is, I don't care if I doubled it. Okay, and then square root x squared plus 2x plus c. Okay, from here, you have both because it's your general solution, but you're about to have to pick one. So if my point is f of 0 is -2, which of these am I going to choose to match? The negative. So it'd be -2 equals negative square root 0 squared plus 2 times 0 plus c. These guys go away, so really it's just the square root of c. So if -2 is negative root c, remember you can square both sides. When you do that, the negative is going to cancel out on its own. So -2 when I square it is a positive 4. Negative square root when I square it is just a c. So we know that c is 4.
So in the end, it doesn't matter if you choose negative or positive, right?
Well, it does, because at this point right here, I have to choose the negative. You can't, in your particular solution, you can't leave it optional as a plus or minus. You have to choose the one that matches your point. Does that make sense? But you're right, your C would have come out the same either way, but your thing would have been wrong if it didn't have the negative. Okay, turn the page.
Okay.
You have to go rewrite the question with the C, right?
Yeah, I did it right there. You should do that, yes. Okay. Ooh, good. Look at this one. Okay, so it says find the x-coordinate of the critical point, determine whether it's a relative min, max, or neither. Then it wants you to find concavity, and then determine the function of f. Okay, so let's think about some stuff real quick. So f of x is defined kind of strangely. Okay, it says f prime is 4 minus x times x to the -3. That is not typically how you would do a sign chart. How would you rewrite that? to do a sign chart on it. What could you do with this negative exponent? Bring it to the bottom. That's what I would do. So this is really 4 minus x over x cubed. And notice that that's already factored and everything for you, right? What are my two critical numbers? You should get two critical numbers. X equals 4. And remember, critical numbers can make it 0 or what? Undefined. So if this x on the bottom is there, 0. Now, go back and look at the question. What does it tell you about x? It has to be what? Greater than 0. So I'm going to go back and cross 0 out. Okay, if they hadn't said that, 0 would count as a critical number. But since they're telling me only consider greater than 0, we don't have to worry about it. Okay, set up your line chart. Remember, f prime on the bottom, f on top. 4 is my critical number. And then really, I'm going to put 0 here because we're not considering numbers to negative infinity. Okay, let's say I plug in 1. What is 4 minus 1? Positive or negative? Positive. Divided by 1 cubed is also positive, so you get a positive result. Okay, then say I plug in 5. 4 minus 5 is negative. Divided by 5 cubed. Positive overall. Negative. Now remember, f prime tells us what f is doing, so f was increasing then decreasing. Then what type of extrema is 4?
X.
Relative max. Very good. So, at x equals 4, f has a relative max. Because f prime changes plus to minus. Okay? And then also notice that it says find the x coordinate of the critical point, so they're not giving you options for there to be more than one. They're reminding you there's only one. Okay, part B says find all intervals where f is concave down. Okay, you have a couple of options here for your concavity. What derivative do we need? We need the second derivative, right? So if this is the first derivative, I need to take the derivative again. You have two choices. Okay, if you leave it like this, what rule are you using? That would be product rule. If you leave it like this, what rule are you using? Quotient rule. Now, it doesn't matter which way you do it. I'm not going to do it either of those ways. This is how I'm going to do it. Okay, for part B, I'm going to rewrite f prime of x like this. Okay, I'm separating it. Now, let's talk about why I'm allowed to do that. There's only one thing on the bottom. So if I want to separate them, I'm kind of like uncommon denominatoring it. So I'm separating them each into their own fraction where they have the same denominator. Okay, now, why is that easier? Well, this is going to reduce to what? So it's going to be 4x to the negative 3, right? And then if I have an x over an x cubed, that's really just an x to the negative 2. Now keep in mind, that's f prime. So I'm still going to have to take the derivative, but now I kind of am swerving around having to use product or quotient rule. Okay? So let's do f double prime. So the derivative, I'll multiply my negative 3 down. Now it's a negative 12. Then it'll be x to the minus 4. Then I'm multiplying my negative 2 down. Now it's a plus 2. X is to the negative 3. Okay, then from there I'm going to rewrite it. That's a negative 12 over x to the 4 plus a 2 over x to the 3. Now, the downside for you choosing to separate is that you're going to have to go back and get a common denominator, but it's not hard. What do they need to match each other? This one just needs an x. So I'm going to multiply by an x here and here, and now they match each other. I can combine it back into one big fraction. So I'm going to have negative 12 plus 2x over x to the 4. Now, notice that the original form that they gave it to me in was already factored for me. Is this one factored? What am I going to have to take out of the top? A 2. So I'm going to take my 2 out. That's a negative 6 plus x left over. So far, so good?
Ms. Turner, you know we're going to Uchida.
I do. I can't wait.
And her.
Y'all are all in. Isn't Jasmine going to?
No. No,
You know, I've never earned.
Oh.
I've never owned a clothing with burnt orange on it.
It's not the best color, I'll be honest. Especially if you're sunburned, then it's like,
I hated Texas until I
wow. Well, glad that you're going there. That's gonna be great.
You should be too.
I didn't hate it, and then realized I was gonna go there, and now I love it. So.
Are you gonna play baseball there? Aww. Huh? Oh. What D are you? Like D2?
I can play 3.
You could have played D3.
Yeah.
And then it goes up in
I
hardness.
never really wanted to play D3. But no, you can't play baseball there unless like they gotta give you a.
I was gonna say, they have like a really good team. Okay, refocus. Top, what's gonna make it 0? 6, and then remember that off the bottom, I would normally pick 0, but not because they said x greater than 0. So 6 is my only number. Set up your line test. Okay, smaller than 6, say I pick 0, because that's easy. Or actually, we can't pick 0. Let's pick 1. Negative 6 plus 1. Overall, what's my sign? That'd be negative. Okay, then pick a number bigger than 6. Maybe you pick 7. Negative 6 plus 7 comes out positive. Now remember, if that's f double prime, what does that tell us about f? Concave down, then concave up. So is there a, what was the question asking originally? Where is it concave down? So I would say it's concave down on 0 to 6. Now I'm going to put because, you don't have to do this, but it's good practice. We'd put f double prime less than 0. Okay? Alright, last part, part C. Okay, part C says, given that f of 1 is 2, determine the function f. So I want you to think about, we have f prime, it was this, 4 minus x times x to the negative 3. They want us to find f. Is that a derivative or an integral? An integral. Now, if you were in BC, they learned integration by parts. You're not. So you can't do this unless you rewrote it like this. So even though that did make part B easier, but it wasn't necessary, in part C it is. You can't integrate a quotient like this by hand unless you can separate it. So we're going to go back to that version. Remember, we already did this. And we're going to do the integral of it. But we're going to use just normal power rule. So when I integrate this, what is the first step going to be here? Remember, you're adding 1 to negative 3. So that'd be negative 2, right? Because I add 1, I get a negative 2. Then I have to divide by negative 2 here, so it'd be a negative 2. Okay, then here I have to add 1, but it's already a negative 2, so that'd be a negative 1. But then if I divide by a negative 1 on a negative 1, I get a plus 1. And then plus c. Now, I didn't label this, but if I integrated f prime, what is this new function? F of x, right? Because we did an antiderivative. Okay, then from here we know that f of 1 is 2, so we just have to go back and find our c. You would not have to put the 1 there. So it'd be negative 2, 1 to the negative 2, 1 to the negative 1, plus c. Okay, but 1 to any power is just still 1. So really this is negative 2 plus 1 plus c. Combine these two guys here, you get a negative 1, then what's c when you solve it? 3. Very good. Now, another thing that if this wasn't a 1 made the problem significantly easier, but you might have had to rewrite it like this. Remember that this is the same as what we wrote here. So if it was like a 3 or something and you were going to have to actually find c, that rewrite might have helped you. But remember, your negative exponents, just shift them down to the bottom. Then I'm going to cross out my c, plug in my 3, boom, we're done. Good? All right. I think we have a couple left to pick from. Good on that. Let's do this one about this little squirrel. No, the squirrel's too easy. Okay, I'm going to bring y'all a calculator. Let's do the rain can one. Right here. Some of y'all, this is kind of like the chili pepper question that was on the mock exam. So, calculator, Zach, you have one, got one. Okay, go ahead and type in the S that they gave you. Want one? Ooh, you have your own, okay. So, type it in. And then I want you to just read through each of the parts, see what you can do on your own before I help you with it. Also, think about how you're going to set up your graph. So remember, they're going to give you X's, then we learned some skills, hopefully, to find what Y's to pick and all that stuff. Okay, so first let's just talk about part A. Part A, what are you doing? Your choices are, if it's a calculator question, a derivative, an integral, a y value, or an x-intercept. That's really all you're ever finding in the calculator. It is an integral. Very good. Now, how do we know that? If this is the rate water's rising, it'd be in millimeters per day, right? And I want to know what the height is. That would be measured in millimeters. So if I'm going from millimeters per day to millimeters, that's an integral. Now, what will you integrate across? 0 to 60. Very good. So for part A, I'm going to set up on my paper integral 0 to 60. And then I'm going to put my s prime of t right here. dt. Okay? Then if you haven't already, remember we talked about your window. You want to set it from 0 to 60. But then to know how to set your y values, I'd look at the table. Okay, so when I look at my table here, I see that all my numbers are around 1, 2, maybe they go up to like 3 at some point, but they're not very big. So I'm going to adjust my y-min to be from -10 back to 10. Just so that it's like a normal window and not crazy. From 0 to 60, and then I did my y's from -10 to 10. And remember, you can pick those values just kind of looking at the table and seeing how big they are. Okay, so I'm going to do second trace. I'm going to do my integral option, which is number 7. And then I'm going to go from 0 to 60. Notice it's going to shade in all of your little pieces for you. 171.8134. 171.8134. Now remember, on the AP test, some of y'all on your test, I don't think it was any of y'all specifically, went to 2 decimal places. You don't get a point. Don't do it. Okay, you need to go to at least 3. Okay, part B. According to the model, what is the average rate of change in the height of the water in the can over the 60-day period? Show the computations that led to your answer. Okay, so this one is tricky. Did they say the words average rate of change? Okay, what are you already looking at though? I want the average rate. What do I already have though? A rate. So, am I taking the average rate of change of this if they're both rates? No, what are you doing instead? Average value. Okay, so it would be 1 over 60 minus 0, 0 to 60, s prime of t dt. Okay, now that was really tricky the way that they phrased it, but you have to think about if this is a rate and I want an average rate, that's an average y value. Because this is a rate, that's a rate, they're the same thing. Okay? Then from there, you would do that in your calculator, but remember, I already know this number because I literally just did it. So I'm just going to put that over 60 and call it a day. That's the average rate. Now, normally it says indicate units of measure, which it does. So I want you to think about if my rate was how fast the water height is changing, what would my rate be here? The same. So it'd be millimeters per day. Okay? Because it's a y value, so it's going to have the same units. Average y value means same units. Okay? Yes?
I use A-Rock.
Yeah, and so this was phrased to trick you to do that. Here's why it's not A-Rock. Because this is already the rate of the rainwater, and you want the average rate of the rainwater. So because these are both average rate and a rate already, that's why it's actually average value. They did phrase it, though, to try to get you to do that, to trick you.
I still got the same answer.
What? You did, hold on, 171.8134 divided by 60. You got, and then you did it this way, you mean? y1 of 60 minus alpha trace y1 of 0.
I didn't use the rate.
Okay, yeah, because this would have been average rate of change. Would have been if you'd done f of b minus f of a over b minus a. Okay? All right, part C, give it a shot. Part C, give it a shot. Says, at what rate is the volume in the can changing at time 7? Okay, this one's a little bit tricky. I'm going to give you the volume of a cylinder. Okay, how do you find the volume of any three-dimensional shape? Do you remember? Base times height. Okay, now, it's a can. What shape is the base? It's a circle. Okay, so what's the area of a circle? Pi r squared h, right? Okay, now, I want to know the rate that the volume is changing, right? That means I'm going to have to take a derivative. Are we on the same page so far? We're taking the derivative of volume, but before you do that, I want you to think about what's a variable and what's the same. Think about a can. And I'm filling it with water. Okay? Is the height going to be changing as I fill the can? Is the height going to be changing? Of the water, yes. Okay, yes. Is the radius of the water going to change? As I fill it up, what's going to happen to the radius? It's going to be the same the whole time. That means you can plug that in as a constant before you take the derivative. So it tells me up here that my radius is 10. My radius is always 10. From the top of the can down to the bottom of the can, my radius equal to 10 is a constant. So I'm going to plug that in right here. Pi 10 squared times h. And then I'm going to change it one more time before I take the derivative. 10 squared is really what? 100. Okay, so let's take the derivative. What is the derivative of v? dv dt. And what is the derivative of 100 pi h, if h is really like to the first power? Okay, 100 pi, multiply the 1 down. What happens to the power on h if it was to the 1 and I take 1 away? H to the 0, but then what do you have to put at the end? Yes, dh dt. Okay, and now think about, how am I going to know what DHDT is? Well, think about what that stands for. DHDT is how fast the height is changing, and what did they give you? The rate of the height. So how am I going to know what this value is? I'm going to find what was the letter they picked? S prime of 7. And I'm going to plug that in for that value.
So you're plugging into the equation they gave you.
Yes, you're plugging into the equation that's already hopefully in your y equals. So go down to 7 in your table. Okay, let's find how fast the depth of the water is changing at 7. It says it's 1.9169, and that's what I'm going to plug in for my DHDT. So remember, DHDT is how fast the height is changing. That's the same as the S prime that they already gave you. So then I would plug that in here. 100 pi, 1.9169. And then remember, you could leave it at that. That's good enough. Now, it does say indicate units of measure. If this is volume, what would I do with my millimeters if it's volume? Cubed millimeters per day. What if it was area? It would have been millimeters squared per day. Okay? All right, very last part, part D. Okay, it says during the same 60-day period on Monsoon Mountain, it accumulates in a can identical to the one in Stormville. The height is blah, blah, blah. That's measured in millimeters. That's measured in days. Let D be this. Apply IVT to the function to show there must be a time when the two cans are changing at the same rate. Okay, so just kind of generally think about how do you do IVT. You plug in the endpoints, right? So what would my endpoints be here? 0 and 60. And then you would be wanting to show that if they're the same, what would this difference have to come out to be? 0. So you'd be plugging in 60 and 0. Hopefully one of them comes out positive. One of them comes out negative. And then 0 would have to be in the middle. Okay? So I guess we're at 458. We can still do it. Okay, type it in. Type it in as your y2. So it would be 1 over 400, 3x up to the 3, minus 30x squared, plus 330x. And there is actually one thing that's tricky about this. Okay, what is S already? It's already a rate, right? Okay, so they already gave me S prime, but they're asking me to plug into M prime minus S prime. Did they give me M prime or did they give me M? M. So make sure when you plug in your two values, you're going to use your regular y1, but you're going to use the derivative of y2. So let's try that in the calculator. I'll show you. So first we're going to plug in 0, then we're going to plug in 60. Okay? So here's my calculator. Okay, I have my y1 is already a derivative, my y2 is not. So I'm going to do y1 of 0 minus, actually I'm setting these up backwards, so let's fix it. Which one do they want me to put first? M needs to come first, so clear that out. I'm going to do math 8, the derivative with respect to x of y2 at 0 minus the y value of 0 of y1. So it's the derivative of Monsoon Mountain minus the y value of the function they already gave me. Okay, that's my first value. It comes out negative. Now let's find my second value and see if it comes out positive, because that's what we want. So math 8, d dx. Did you type in 0 or 60? Okay, I'll come look at it. Okay, and so one came out negative, one came out positive. That means it has to hit 0, and 0 means they'd subtract. They'd have to have been equal. Okay. Let's see. That was a cube. You took it as square. That's fine. Okay, makes sense? So then you just put IVT guarantees this, that M prime equals S prime because they labeled it D. D of 0 came out to be negative 0.6749, and D of 60 came out to be 69.3773, and 0 is between these values. Okay. Good job. Sure. You mean like that? Just put it up there? So it would have been the derivative of monsoon at 60 minus, and then the y value of whatever Rain Mountain can at 60. But the tricky part was that one of them was already the derivative and the other one wasn't. So you had to kind of think about that.